Assalamu alaikum wa rahmatullahi wa barakatuh. My name is MAZEN. I am studying a master's degree at King Abdul-Aziz University in field of mechanical production and control system design. Today we are going to present our work or our projects for compressor wind blade turbine. So let's start to present our work. Here we are. First of all, our project's topic: mechanical behavior of gas turbine rotator blades made of composite with and without material properties grading. This is our agenda. First of all, we will talk about the general information about the compressor blade turbine or wind blade turbine. Then we will going to talk about the main loads on blades, project methodology, material selection, finite element analysis in general, composite material, static structural analysis, finite element analysis of gas turbine blades, result and discussion, conclusion, and future work. First, let's take general information about the compressor engine. Compressors are devices widely used in almost all the fields of engineering, like civil, mechanical, and electrical, and so on. As day by day, population of worlds is increasing, and our resources are frequently reducing. Hence, to meet this demand of the worlds of energy, we have to move to a device which have a maximum efficiency for the condition. Turbomachinery. Turbomachinery are better suited machines having a good efficiency, in which a gas turbine is the best example of turbomachinery. Turbine is the parts of gas turbine which provides the power to compressor to run or provide power to external source from where energy can be extracted by attaching alternator in the shaft of gas turbine. So this is our example for application in gas turbines. We can use it in the power plants and a lot of equipments or parts. Location of turbine compressor engine. The turbine compressor usually sit at the front of the engine. There are two main types of compressor: the centrifugal compressor and the axial compressor. In both types, the compressor rotates and it's driven by a shaft that passes through in the middle of the engine and is attached to the turbine as shown. So as we can see here, this is the compressor engine. First, we have the air inlet to the compressor. Then it will go into the combustor. After that, going to the turbine blades. Then going to the power turbine. In the power turbine, we have two outlets. Some of them going for exhaust, and other to run the shaft. Compressor turbine technology. The compressor will draw in air and compress it before it's feed into the combustion chamber. The purpose of turbine technology are to extract the maximum quantity of energy from the working fluids to convert it into useful work with maximum efficiency by means of a plant having a maximum reliability, minimum cost, minimum supervision, and minimum starting time. The gas turbine obtains its power by utilize the energy of burns gases and the air which is at high temperature and pressure be expanding through the several ranges of the fixed and moving plates to get the high pressure of order 4 to 10 bar of working fluids, where the fuel is continuously burned with the compressed air to produce a steam of hot. Compressor engine parts. We have three parts of compressor engines. First, the compressor section, then the combustion section or combustor, another name. The last one, the turbine and exhaust section. A turbine blade is an individual component which makes up the turbine section of gas turbine. The blades are responsible for extracting energy from the high temperature, high pressure gas products by the compressor. Blade turbine. Gas turbine blade is very important component in engine as they are attached to both turbines or compressor. And turbine provide the energy to the compressor, hence the turbine blades are more important component to enhance the efficiency, which will be analyzed on the base of blades, high area of fluid flow. The rotator blades of the turbo machinery are very critical components and reliable operation of the turbo machinery or turbo machine as a whole depends of their reliable operations. The major case of breakdown into turbo machinery is the failure of rotator blades. The failure of rotator blades may be linked to the catastrophic consequences, both physically and economically. Hence, the proper design of the turbo machine blades plays a vital role in the proper functions of the turbo machines as shown. Here, this is the one sample of blade compressor blade turbines. This is a video to show you how the compressor blade turbine work. As we see in the video, how the blade turbine is working. Our projects in this paper, we will analyze the blades from the first stage of a high pressure turbine are compared based on their geometry. Other properties such as the material are assumed variable because we have a lot of types of material that we will use in the projects, and we can see it in other slides. The numerical approach which is used in this study is resident in structural analysis. Rotator blades of gas turbine has been analyzed for structure using ANSYS 12, which is powerful finite element software. In this project, we are going to use the ANSYS to analysis or analyze our materials. This project will present the failure analysis of the turbine blades of gas turbine engine installed in the curtain type of sample system, consisting of the gas turbine driving an electrical power generator. Finite element method was utilized to determine the stresses status of the blades under operation condition. This is our project timeline. We are worked for 7 weeks lecture review, then project writing, project submission, finite element analysis, result review. It's talk with us 2 weeks, finish project writing and project submission. Project methodology. The project is performed in 3 stages: are theoretical analysis, creating solid model, and finite element analysis. In theoretical analysis is performed by studying the concept of design and material used in the plates. The function of the plate is to convert the mechanical energy to electrical energy by the extraction of energy from the high pressure. Secondly, of the methodology, creating geometric model in ANSYS. 3D geometric model of compressor plates is created in ANSYS for further analysis. Like we are going to study the stresses, the deformation, and so on. And the last type of methodology, finite element analysis. There are 3 steps in finite element analysis called pre-processing, solution, and post-processing. In pre-processing, modeling definition includes define of geometric domain of the problem, the elements type to be used, the material properties of the elements, the geometric properties of the elements like length, area, the element connectivity, mesh, the model, the physical construction, boundary condition, and the loading. Here, as we can see in the photo or the pictures, finite element modeling, our step to design and analysis the wind plate or compressor plates turbine. First, we are going to make geometry, generate the geometry, then define material properties, define composite, generate finite element mesh, define the boundary condition like displacement and load. Then we solve in post-processing parts and see the result. Before we analysis or design the plate turbine, we should know the loads on the plates. The main loads on the plates, gas forces acting on the plates of the rotator in the general have 2 components, namely triangular and axial. This force results from the gas momentum change and from pressure difference across on the plates. These gas forces are evaluated by contracting velocity triangles at the inlet of and outlet of the rotator plates. The rotator plates considered for analysis are twist and same profile is taken throughout the length of the plates. If the gas forces are assumed to be distributed evenly, then their resultant acting through in the centroid of the area. After we know the mean load on the plate turbine, we should know the required properties of the wind plate turbine material. In this material, if you are going to selection, we should take care about some points. First, width availability, low distance and low cost, tensile strength, resistance of high frequency vibration, fatigue stress, high corrosion and fatigue resistance of the to withstand cycle loading, high stiffness, high fracture toughness, the ability to withstand environmental impacts such as humidity and temperature, low frequency thermal fatigue stresses, resistance to erosion and corrosion. How to select the material? The common material used to compressor plate are tensile. There is some mistake here. Tensile steel. This is the common material that used for compressor plate turbine. Tensile steel 400 series and type 403. This group of alloy have properties that including good ductility at high strength level, a temperature up to 755, high resistance to corrosion is also obtained because of the high content. One of the main objectives of the projects is to find out suitable material for a windmill plate. Usually, the plate used in the fiber reinforced material. The material used for the current experimental of are structural steel. For example, we used 6 types of material: structural steel, epoxy carbon, E-glass, S-glass, aluminum alloy, and FGM. three type of our from 6 material that we will use in the project is composite material. So let's take some information about the composite material. Composite material consists of the two or more materials combined to obtain properties difference from those individual material. Composite material consists of the two phases. We have two phases of composite material, matrix phase and the reinforced phase. As we can see here in the figure, composite material based on matrix, we have three types: ceramic matrix, polymer matrix, metal matrix, and for polymer matrix we have thermoplastic matrix and thermoset matrix. If you are going to see the composite material based on the reinforcement, as we said before, two phase or two type of composite material. First, we talk about the composite material as a matrix, based on matrix. Now we are going to talk about based on reinforcements, fiber and particulate and structure. You can stop the video and see this figure. Material. Here, matrix phase in the divided into three types. First, polymer matrix composite. Polymer matrix composite is for thermomestic resist and the most widely used polymers, epoxy and plaster, are commonly mixed with the fiber reinforcement. Secondly, metal matrix composite include mixture of the ceramics and metals such as cement, carbides, aluminum or magnesium, reinforced by strong, high stiffness fiber. Last type, ceramic matrix composite. Last common composite matrix. This is our use for high temperature application based on reinforcement. It's classified into three subdivisions. This three subdivision for polymer matrix composite. First, fiber reinforced composite. One of the fiber phase and other is matrix phase. The fiber phase helps to enhance strength and stiffness, whereas matrix phase binds fiber together. There are three mainly subdivisions under fiber reinforced composite based on the polymer matrix composite. Matrix polymer composite, it's divided into glass fiber reinforced composite, carbon fiber reinforced composite, and armate fiber reinforced composite. Now we are going to talk about the glass fiber reinforced composite. Glass fiber reinforced composite. This material, three type of material which we used in our projects, the most common reinforcements for polymer matrix composite is glass fiber. Most of the fiber are based on silica with additional of the oxide. It's divided into three main classes: E-glass, C-glass, and S-glass. Particle composite, and why we are going to use the composite material. In order to ensure the required shape, stability, strength, and damage resistance of the compressor rotated blades, the blades are product from long fiber reinforced polymer laminates. In this composite, long fiber ensure longitudinal stiffness and strength, while the resin matrix is responsible for structure toughness, delimation strength, and out of plan strength and stiffness of the composite. Description of material. The main goal of this project is to reduce the cost and weight of the compressor turbine blades by using another form of material. For that, we are going to design the geometry of the blades in the 3D model ANSYS workbench. The result that we have got after simulation are compared with those obtained using structural steel, epoxy carbon, E-glass, aluminum alloy, and FGM. To determine if the new composite material is qualified to be used in domestic wind turbine, considering the difference in environmental condition. Selection material for study. The mechanical characteristic of the structural steel, epoxy carbon, S-glass, E-glass, aluminum alloy, and FGM material are summarized as we can see here. Turbine blades are subjected to very strenuous environments inside a gas turbine. They face high temperature, high stress, and potential environment of high vibration. All three of these factors can lead to blade failure, potentially distorting the engine. Turbine blades are carefully designed to resist these conditions. As we can see, this is summarized of properties of material of structural steel. This is here we are talking about 6 properties here: density, Young's modulus, Poisson ratio, shear modulus, tensile stress, and shear stress. Second material that we will use in our projects, E-glass. This material is used when the strength and high electrical resistance are required. This is the properties of the E-glass. You can stop the video to check the numbers or the values. The third type is glass. S-glass, high strength glass. S means from strength. Developed in 1960 for military applications. Has that means S-glass has 40% higher tensile and fracture strength, and 10 to 20 higher compressive strength and fracture modulus than E-glass. Contain magnesium and aluminum silicate, mostly used where high strength and high stiffness, extreme temperature resistance, and corrosive resistance is needed. As we can see here, the values of the mechanical properties for S-glass. Fourth material that we'll use in our project, epoxy carbon material. In this composite carbon acts a high performance fiber material because it has high specific modulus and high specific strength of all reinforcing fiber materials. Is a strong, light, and very expensive material. It's extensively used in racing cars. High cost of this material is composed by excellent strength to weight ratio. This is the mechanical properties for epoxy carbon. This is the value. Aluminum alloy material. Aluminum have been mostly used in the aerospace manufacturing mainly due to high strength to weight ratio. Aluminum alloy typically have an elastic modulus of 70, which is about 1/3 of elastic modulus of steel. And steel alloy, it has a high tensile strength, weldability, and corrosion resistance. This is the mechanical properties of aluminum alloy. This is the value of the properties that we'll use in the projects. Frictional grade material, FGM. As FGM mechanical properties change with the direction, as we can see here, if someone who don't know what's the meaning of FGM, FGM will use 2 types of material. Let's first talk about FGM, then I can explain to you how FGM worked and how we are going to use in our project. FGM mechanical properties change with the direction. The isotropic material is not enough to represent and modeling them. There are several methods to predict the FGM properties change, such as power law function method, slabed function method, and exponential function method. We are going to use power law to describe the volume fraction science. It's the most used method. Here, this is the mechanical properties for FGM. Here we use 2 types of material. So let's say material 1 and material 2. Material 1, it will start from some area or at the beginning of the wind blade turbine, and it will come increasing from, for example, here 100% of the material. Then it will reduce up to when it will arrive to 50% of material number 1. Then material number 2, it will start. Then that's mean in one parts we have 2 types of material. This it will help us to find some good mechanical properties and for special using. In ANSYS there is no FGM material. That's mean you will make it. So we make calculation Excel sheet between 2 types of material. Then we take the average. After that, we make a new add a new material in ANSYS, and we make the name FGM material. Then we put the value of mechanical properties. After that, we use it as a material. After before we are talking about the material selection, type of material, mechanical properties of our materials. Now we are going to talk about the structural steel analysis. Turbine blades are subjected to stresses from centrifugal force. Turbine stage can rotate 10,000 of revolution per minute, and fluid focus that can cause fracture, yielding, or crab failure. Additionally, the first stage, the stage directly following to the combustor of a modern turbine face temperature around 2,500 Fahrenheit, up from temperature around 1,500 Fahrenheit. In early gas turbine, those high temperature weaken the blades and make them more susceptible to crimp failure. The high temperature can also make the blades susceptible to the corrosion failure. The static structure analysis of turbine blades is done using ANSYS, which is deducted finite element package used for determining the stresses and formation across the turbine blades. Structure boundary condition to be applied on the rotator blades. 2 structure boundary conditions, namely displacement and force, were applied on the rotator blades model. Finite element analysis of gas turbine blade. The turbine blade is analyzed for structure performance due to the loading condition. Static analysis was carried out to know the mechanical stresses and formation expanded by the gas turbine rotator blades. This includes the parameters such as the gas forces, which are assumed to be distributed evenly. Also, the triangular and axial force acting through the centroid of the blade. The centrifugal force acting through the centroid of the blade in the radial direction. So, as we said before, in finite element analysis, we have processing and periodic processing and result, or finally the results. In the first step of finite element analysis, we are using the meshing pre-processing. Meshing in the first pre-processing stage in ANSYS analysis, meshing are done on the model to substitute the value of input parameters. Meshing is done by defining this model into the geometry. The mesh of difference section in the wind turbine blades was made using ANSYS workbench software figure, as we can see in the figure. The main rules of the mesh into divided the geometry of the wind turbine blades into small elements. Each of those elements will have a set of parameters such as pressure and wind speed on their location. For that, a small element of the shape have been used. More the mesh is fine, and more the size elements are smaller. And the result will be variable. However, if the mesh is too thin, small problem has been detected, such as a long computing times or corrosion problem. The choice of mesh size is the most important step in the calculation process. As we can see here, this is our wind blade turbine workbench, and this is meshing process. Here the number of nodes and elements as we can see at the corner. Here meshing details, we have 27,000 number of nodes, 15,000 number of elements, element size 100 millimeters. Boundary condition, we have three boundary condition on the blade compressor blade turbine. Blade rod is fixed, pressure is applied normal to rotate blades model. At the middle of the blade displacement fixed in Y and Z direction. This is our fixed support. We fix the compressor wind blade turbine from base metal. Here we acting or apply the force in X direction with 800 radian per second, and we fix it in two components in Y and Z direction. This is an analysis result post processing. First, analysis using structural steel as a blade material. So this is the result for structural steel material. This is the total deformation effect for structural steel. As we can see at the corner, this is the maximum deformations when we use the structural steel material. Here the form is stress affecting structural steel. As we can see here in the base metals, there is too much stresses. And you can see the value on another slide. Here, analysis using epoxy carbon as a blade material. Here, the formation also, as we can see at the corner, this is the value of the formations. The units meters. Here, this is the formation stresses for epoxy carbon, and the units Pascal. Analysis for E-glass blade material. This is our total deformation. Here stresses. S-glass total deformations. Stresses. Aluminum alloy. As we can see, the deformation, also the stresses. As you can see here, this is the mean. This is the maximum stresses. This is FGM. We add the material, as we can see here. This is the deformation that affect an aluminum alloy. Analysis result. First, we make compare and stresses. As we can see in the table 8, it indicated the stress distribution in the compressor plates made up of structural steel due to the mechanical load. Stresses distribution increasing from center of the plate to the plate base. Maximum equivalent stresses observed is 4.471 Pascal. This is the stresses for 6 types of materials. This is our results. Here, compare for deformation. In table 9, showing the deformation in the turbine plates made of structural steel due to forces. Maximum deformation 7.242 is observed that the plate in the top corner section and minimum at the base of the plates. Sorry, but we want to check the battery. Here, the second compared for the deformations. In this project, we make two type of analysis: deformation and stresses. Here, for deformation, table 9 shows the deformation in the turbine place made of structural steel due to forces. Maximum deformation 7.242 is observed that plate top corner sections and minimum at the top corner sections and the minimum at the base of metal of plates. Here, the compression of deformation stresses that affect on the plate composite plate turbine. This is the deformations value for structural steel, epoxy carbon, E-glass, S-glass, aluminum alloy, and FGM material. Here, the compression of all materials, as we can see, for three types of convert and deformation stresses mass. As we can see, structural steel's mass 0.141 kilograms, epoxy carbon 2.6, E-glass 3.5, and so on. This is the compared with the stresses mass deformations. Here we can see the compression of stress that affect on the plate, on the compressor plates in bar graph. And FE modeling results. Based on the FE modeling, the pressure distribution, deflection, and the stresses distributions on the winch compressor plate under 6 material condition are expanded. Compression of deformation in paragraph. Here for mass, we compared all the material. Here for all materials in paragraph. The result: the design and static analysis of composite gas plate turbine had been carried out in this work. Comparison between different composite material are made under same load condition. Stresses, strain, and deformations are calculated using ANSYS. Discussion. The result obtained from analysis implies that epoxy carbon and structural steel show overall lasted value in stresses and deformation. But in case of mass structural steel shown drastic variation, thus it can be concluded that epoxy carbon is more suitable in making windmill blades. Six structural steel, epoxy carbon, S-glass, aluminum alloy, and FGM E-glass used for manufacturing of turbine blades of gas turbine engine are meant for marine application, and they have been selected the turbine blades model profile generated by using ANSYS software. The turbine blade analyzed for the structure performance due to the loading condition in ANSYS. Structural steel has a maximum deformation as compared to the other materials. The maximum equivalent stress for structural steel is 4.471. This is our recommendation for future work. This methodology can be extended for different material, intelligence material, to get more efficiency and better performance in the near future. The material should have the high melting points, thermal conductivity, and different densities. The turbine blades can be further studied as the use of the turbine is increasing in the industrial because of increasing having maximum efficiency as a resource are diminishing day by day. If there is any questions for our presentation or our projects, please make it at the comments. Thank you.